Hello, grade 11s. In this lesson, we're going to start talking about stoichiometry. Hopefully, by now you're okay with the mole and the concept of the mole, and we will continue with this. So, stoichiometry just takes the idea of the mole one step further and now begins to compare moles of one substance to moles of another. Okay, and you can think of this as just comparing in a balanced equation the coefficients that are in that balanced equation. So, and using them as ratios or proportions. So if we're going to write then, just practice writing a reaction that has this. The reactants have one molecule of nitrogen gas, and three of hydrogen gas. And products would produce two molecules of ammonia, NH3. If you were to write that out, it would look like this. Right? Fully balanced equation. We can use this balanced equation to say for every 1 mole or 1 molecule of nitrogen, we need 3 of hydrogen and 2 to produce 2 of ammonia. So it's the same thing as saying a mole ratio then of 1 to 3 to 2, right? 1 to 3 to 2. And this is what's called a mole ratio. So what you need to get from this lesson, the main thing really is the calculations and practice that'll come later. So don't worry about the few examples I have for you now. It's the mole ratio that's really important, right? So if you can understand this, that's great. Everything else is just practice. Okay, so let's do that now. How many moles of NO are produced from 3 moles of NO2 in this reaction? All right, so in this balanced equation, reaction, we have a mole ratio here of 3 NO2 to 1 water produces two of nitric acid and 1 of nitrogen monoxide. Okay, so question is, how many moles of NO are produced from 3 moles of NO2? Well, we have 3 moles of NO2. How many moles of NO are produced? Well, there's an imaginary 1 here, so the answer is 1, right? Because it is a 3 to 1 ratio between NO2 and NO. Okay, how many moles of NO are produced from 6 moles of NO2? Okay, well, using the same balanced equation, we have 3 to 1 is our ratio. Well, now if we have 6 NO2, can take a second to think about what the answer might be. How many NOs do we have? Hopefully you're thinking, you're saying out loud or in your head, 2, right? All because you have a 3 to 1 ratio. Okay, now this can get a little bit more complicated if they're not just multiples of that ratio. How many moles of NO are produced from 1 mole of NO2? Let's go back. 1 mole of NO2. All right, so we know the ratio is 3 to 1, but now it's asking us what if we have 1 of NO2? How many moles of NO would be produced? Okay, some of you might be able to do this in your head, but let's use what's called a proportion method here. So proportion just means you take two ratios and you put an equal sign next to them. Okay, so here's the initial ratio. For every 3 moles of NO2, you have 1 mole of NO. Put an equal sign. Then write down what the question's asking you, or giving you, and also requiring of you. So 1 mole of NO2, right? We have 1 mole of NO2, and we don't have, so we're going to say X. We don't know the number of moles of NO. Notice that whenever you set up a proportion, and we'll continue practicing this in other examples just to drive the point, but notice all of the units at the top are the same. So mole of NO2, mole of NO2. All of the units at the bottom are the same. Moles of NO, moles of NO. It just makes it easier for these proportions to work. Okay? So now that you set up this proportion, you cross multiply. This times that, this times that. I'm going to keep all of the units, so it's going to look a bit funny, but it's just 3 moles of NO times X mole of NO. So you write that down. 3 moles of NO2 times X mole of NO. Do the same thing for the right-hand side. Solve for X, just like you did in grade 9. Solve for X. You can start canceling out units now. Mole of NO2, mole of NO2. What you're left with is X is equal to 1 over 3 which is really 0.3 moles of NO, are produced from 1 mole of NO2. Okay, so this is a proportion method, right? I'll show you other methods, other ways to solve as we continue practicing. Okay, but this is your first stoichiometry problem. All stoichiometry really means is you go from 1 mole of one thing to another mole of another thing using the ever important mole ratio, which in this example was a 3-to-1 ratio. 3-to-1. Okay, now you can put your pencils down, your pens down if you're taking notes. We're just reading this now, we're talking about it. So in the same balanced equation, right, we saw earlier, we can say that number of particles can be considered in this way. We have 1 molecule of NO is required with 3 molecules of H2 to produce 2 molecules of NH3. This is what this reaction means. It can also be looked at another way in terms of moles. 1 mole of nitrogen, 3 moles of hydrogen produce 2 moles of ammonia, all still following that mole ratio. Mass doesn't do that. Look, here we have 28 grams of nitrogen, 6.1 grams of hydrogen, and that produces 34.1 grams. What this shows you is the law of conservation of mass. Yes, you should have the same mass on both sides. It doesn't follow mole ratios. So the point here is mass has no relation, is not proportional, has no relation to mole ratios. Okay? Now for 2 sets of examples and we're done. Okay, so these are, our first set is mole calculations, stoichiometry questions with mole calculations. So we begin. So here it says, how many moles of H2 are produced if we have that many moles of O2? Okay, so we have a known value of moles of O2. Question's asking how many moles of H2O do we get? Okay, and the ratio between the two of them is 5 to 6. Look, 5 to 6. Okay, so let's figure this out. We're going to use, and I think in this first example, we're going to use the factor label method. So always write down the number of moles, right, of H2O, write down what you need, write down what you're given. So you're given the number of moles, 176 mole O2. I'm going to multiply that by your mole ratio. Whenever you're doing stoichiometry, it's always your mole ratio. And think of that as your conversion factor. You're converting from 1 mole of one thing to 1 mole to another mole of another thing. Right? So also mole of O2 goes at the bottom. Right? The unit you want to get rid of goes at the bottom. The unit you want to keep goes at the top. The unit you want to keep is here, mole H2O. Okay, now what numbers in the balanced equation are associated with H2O? H2O right there, 6. O2 is right here, 5. Okay, look, these cancel out as they should, right? And you're left with okay, so the correct number of sig figs would be rounded to here, to this digit here, so 0.211, because we should have 3 sig figs, 1, 2, 3, right? And we'll talk more about sig figs later. Okay, so next, how many moles of NO are produced in the reaction if we have 17 moles of H2O? Okay, so here we're being asked for the number of moles of NO, of this, okay, given a certain number of moles of water. Okay, so before in this example we went from reactant to product. Here we're comparing 2 products, the mole ratios between 2 products, which in this case is 4 to 6. So in the 4 to 6 ratio, or we can reverse it 6 to 4, depending on what conversion factor we need and where we need to place those units. Okay, so we need number of moles of NO, right, following the same format. We have 17 moles of H2O. You can multiply that. Now you don't know what to write yet, that's okay. Whatever's here, we write at the bottom. So mole H2O at the top now. Mole of what you want to keep, that's mole of NO. Now, what coefficients are associated with each of these? For NO, it is 4, so you write 4. For H2O, it is 6, so you write 6. Notice units cancel out. and we're left with 11.33 mole of NO. Okay, done. And rounded to the nearest sig fig, it's just with 2 digits because of the 17 here, and your answer would really just be 11. Okay, last set of questions. Now this now involves mass calculations. Okay, we didn't do that before, it was just mole, so this is now, it also involves mass. Good. So here's your equation, right? That's that equation again. How many grams of H2O are produced? If 1.9, so we're looking for mass of water. So first is mass of water. If 1.9 moles of ammonia are combined with lots of oxygen. Okay, so you should always begin by figuring out the number of moles. The mantra we have in class is when you don't know what to do, or even if you do, always determine the number of moles. So although we want grams of H2O, let's first figure out the number of moles of H2O and set up a factorable method to do that. So 0.1, oh, that's the last question here. How can I erase this? I'll figure it out. I'll just need to eraser. Okay. All right. So first, mole. Well, I could have just left that. Mole H2O. Okay, we are given 1.9 mole of NH3. We're going to multiply that by the mole ratio. That will eliminate that. So mole NH3 at the bottom, right? H2 at the top. So mole H2O. And here H2O has a 6 next to it, right? And NH3 has a 4. Cancel, cancel. And we're left with our answer, which I've calculated here is 2.85 mole of H2O. Okay, that's our first step. Next step, we need to convert to grams. So we need mass. Right, what the question is asking us for, mass of H2O. Let's use a factor label method again. In the next question, we'll use a factor label method. So we have 2.85 mole of H2O, okay, times a conversion factor. Know that mole H2O is going to go at the bottom because we want to cancel this out, right? We want to cancel that out, so they have to be the same. And grams of H2O has to be at the top. So what does this look like? Grams per mole. Hopefully you're thinking molar mass, and it turns out to be 1, and 18.02 is a molar mass of water. Okay, these cancel out, and you're left with your final answer, which is 51.4 grams of H2O. Great. Correct number of sig figs, let's see, we have 2, so really our answer here is just 51. Okay, next. Last question. All right, here we're going to use formulas instead. So let's just write that down. Our formula is moles equal to mass divided by molar mass. And we can rearrange this as we need to. We're also going to use a proportion method. So you've seen that once, we're going to see that again. So to solve this, we're going to use the proportion method. Okay, so when you don't know what to do, the first thing you should always do, or even if you do know what to do, the first thing you should always do to remind yourself is figure out the number of moles. In this question, it's asking you for grams of O2. Well, let's find moles of O2 first. So mole of O2. Okay, here we're going to set up a proportion. So considering the mole ratios from the balanced equation here, we have a ratio of 6 moles of H2O over 5 moles 5 moles of O2, and that is equal to, now this is the part that we're going to fill in. This is straight from the balanced equation. The part we're filling in now is number of moles of H2O. We have that, right? It's 0.3. right? What we need though is, we'll call that X. We need the number of moles of O2. So cross multiply as you would to solve any proportion, and you're going to end up with this. I'm going to expand this up here. 1.5, right? Because 5 times 0.3. 1.5, I'm going to write down all the units, mole H2O, mole O2, right? It's just mole O2 times mole H2O, mole O2 times mole H2O. I'm just writing that out. It's equal to 6x, right? I'm just multiplying here. 6 times x is 6x. And then our units are mole H2O, and not enough room here, so I'm going to write at the bottom mole O2. Okay, now notice mole H2O and mole H2O cancel out. Okay, so do these. Okay, solve for x. Write it off over here. X is then equal to, let's see what I figured out here. O2, 0 point, not O2, 0.25 grams. Sorry, not grams, 0.25 moles. Okay, so that's our first part. We found the number of moles, our first part. Next part, not as long, is just converting that now to grams. So a simpler conversion from moles to mass. So let's use a formula. Okay, mass is equal to moles times molar mass from this formula here, just rearranged. We have 0.25 moles. Multiply that by the molar mass, it's 32 from your periodic table, 32 grams per mole, and we end up with, sorry, we're kind of tight here, 8 grams, and that is our final answer, 8 grams. That's your home fun. Practice as much as you can and ask questions. That's it for now.